Hi guys, welcome again, and today we're going to know the answer to the question, what is interval, or what is the intervals? Intervals are sets, simply are sets. Uh, the most important for now, the most important set of numbers are the real numbers, which is centered at zero. Okay, it's not literally centered at zero, it goes to infinity from right, plus, and goes to infinity from left, and there is here a number like 1, 2, 3, and minus 1, or negative 2, negative 3. Okay, so the intervals are sets, but it's filled with numbers. For example, we have two kind of intervals, like open intervals and the closed intervals. Let me start with the closed intervals A and B. The intervals denoted by brackets could be like sharp edges of brackets or just half a circle of brackets. Uh, this contains all the x belongs to the real numbers. We usually put this line to specify that this set as a real number or a set of numbers, and we say that x will be from the from A to B, and x could equal A and could equal B, or can equal A, can equal B. So if I want to plot it here, let me delete this. If I want to plot it here, and so we can say that this A and this B, any two real numbers on R. Okay, this AB interval AB, this called the left bound, and this called the, or sometimes we call it the lower bound, and this is the upper bound of the interval. So x belongs here. For example, if I take the interval 0 plus 1, not plus 1, 0, 1. So this interval contains infinite number of real numbers. So it's not the set. It's not the set 0 and 1. The set 0 and 1 consist of two elements, 0 and 1. But this interval has infinite of numbers, infinite of real numbers. It contains 0, 0 0.1, 0 0.01, 0 point blah blah blah. It contains, and also it contains 0.9, 0 0.99, and 999, and so on. So this line is filled with numbers, with real numbers. There is no gaps in here. So that's the major difference between the sets and intervals. The sets are not intervals, but the intervals are sets, because we can see this brackets, these sets, all it's the set of all real numbers that it's surrounded by A and B, and it could equal to A, x could equal to A and could equal to B. The other interval, which is A and B, see, x equal to R, to the real numbers, x belongs to the real numbers, and x surrounded by, from above by B, and from low by A. Okay, if we want to write just a small demonstration, I'm going to make the circle here, and here A. Okay, as soon as we like plotted a point here, a solid square, this means A and this means B. That means when we put it that way, we mean that the A is included in the interval, okay, and the B also is included. That's why we call this a closed interval. And we're not going to explain why do we call it a closed, but we're going to give a simple notation. If they are included, if the both boundaries from the left and from the right are included, we're gonna call it the closed interval. And this called open interval. This called the closed interval, closed interval. And this called open interval. Okay, these same concept, it contains all the real numbers surrounded by a and b, and they cannot be equal a or equal b. So we're taking all the real numbers that less than b and greater than a. That's it, not equal. That's the major difference between the closed intervals and open intervals. And we have like hyper two types. For example, we call it a and b. See, this is the a included and the b is not included. X belongs to the real numbers. A is included. When we put equal, that means included, and b is not included. We call it this we can call it like half open, open from the right, or half closed from the left. Same thing, doesn't matter. Not set, sorry, interval. And we're going to call it x belongs to the real numbers, and a is not included in the interval, and b is included. Okay, so we have now open closed interval, open interval, half open or half closed, half open or half closed. Okay, if you want just to plot these, I think it's going to be too easy because it's not a big deal. So I'm going to write two circles here, draw two circles here, and after we complete the drawing, we're going to say that this is filled, it means included, and this is here, we fill it, that means included, and also they are called these. Simply, these four kinds are all what you will see in the intervals. We have two other kinds of intervals. The other two kinds are very interesting. I'm going to plot them here so I don't have to use another page, just to be clear to you, so it will be easy to you to compare between the cases. We can write this one a and infinity. What does that mean? That means all the x belongs to the real numbers, but the x greater or equal a, and there is no bound from the right. So it's bounded from the left. Okay, it's bounded from the left, and bounded from the and not bounded from the right. So from the right, it's open. Actually, if you are a mathematician, if you are engineer or physics, you don't have to pay any attention to what I'm going to say right now. But if you're a mathematician, this is a closed interval, and you will learn that maybe in your second year or third year in mathematics. But if you're engineer or physicist or chemist, you don't need to pay any attention whether this is closed or open. You can call it a close from the left, but just leave it from the right. Don't pay attention to it now. And we have the other kind, which is minus infinity from the left and b from the right, and we could write it close now. All the real numbers that are less or equal b. So this interval is bounded from the right and it's not bounded from the left. So we call it also interval. What do we have? We have the other case, which is a and infinity and minus infinity and b. Same cases, but without equal. Or we're going to call here x greater than a, and all the real numbers where x less than b. So now we completed all the cases of the intervals. We have open intervals and we have closed intervals, and just I want to remind you that intervals are just sets, but the sets is not intervals. Okay, so now we're going to learn how to do the operations on intervals. For example, I'm going to do it for a quick. Now, if you want, for example, to find the 1, 2, and for example, I'm going to do intersect, okay, union for easy. I'm going to do union, and I'm going to do, for example, 1 and 2, 5. Okay, so I think I will suppose that you are familiar with the meaning of union. Union just put in all the elements of the both sets without repetition. Okay, so we're going to take all the elements in this, and all, I'm going to call it A, I'm going to call this B, interval or set. Okay, so the union taken all the elements in here and all the elements in here and put them in one set without repetition, without writing the element twice. So for example, I'm going to take this one, I'm going to say this from 1 to 2, and this from 1 to 5. Okay, it's clear that I can write the elements in this interval are all included in the union, and elements in this interval are all included in the union too, including the bounds. So the result will be 1.5. So 1.5 contains all the elements in here and all the elements in here. The other example that I'm going to show, for example, I'm going to take 1.3 intersection with, okay, 2.5. Also, the simplest way to find the answer to the like union, intersection, the difference, I highly recommend if you can just plot lines like I'm doing now to make it easy. So 1, let's say 2, let's say this is 3, this is the first interval. Okay, I'm going to just make them bold just to emphasize that these are closed, and here I'm going to take the 2 and this is the 5. So I suppose you know that the closed interval, the intersection between intervals or sets, consist of the elements that are existed on both sets. So the result here will be all the elements or the real numbers that are existed in here and existed in here. So the first step you're going to find, so for now I can take this is vertical line to say this is the first bound and this is the furthest. In union we take the furthest from the right and the first one from the left. Okay, and I will compare the I will consider the bounds in the other step. Here I'm going to draw just line. This is the common elements between the two intervals. This interval contains those elements, and the second interval contains those elements, and these are here the common elements. Now I consider the bounds. I will ask myself, is 2 in this interval? Yes, it's existed in the first interval. Is 2 in this interval? I will tell him yes, so I'll put it here. I will come to the other line. I will ask myself, is it 3 existed in this interval? Yeah, it's existed because it's a close. What about 3 in the second interval? I will say it's existed because it's in the middle of the interval. So it's existed too. So the 2 and the 3 are existed in both intervals, and all the elements are existed in both intervals too. So they will both existed. So this is the result for the second point. See you in the next lesson.